Okay, buckle up. This one's a little bit complex also. So this whole thing right here is going to be our u. All right. So the derivative, the derivative of 3 is 0, but the derivative of ln of negative 3x, remember, is 1 over the function times the derivative of the function. So this negative, and then that's times dx. This negative 3 and that negative 3 cancels. So du is equal to 1 over x dx. All right. Well, that takes care of this part and this part. So we're going to have to multiply both sides by negative 5, and then that will take care of, here, all of that now will be taken care of by simply putting negative 5 to the left, rewriting this like this, and then this will be 1 over u du. See that? All of this stuff is taken care of. And then down below, so since all of that cancels, we just have 1 over the u. All right? So remember, just like if you had 1 over x, it would be then the antiderivative would be this. So that's what we're going to do here. So the antiderivative, the negative 5 times ln, absolute value of u, plus 0, and that will, the antiderivative of 0 is c. But remember, all of this in here is the u, and the original u is 3 plus ln, also another absolute value. So it's not like there's a lot of steps. It's just getting your brain to think about what's happening. And whenever you have 1 over a u, the antiderivative is going to be the natural log, right? If you had y is equal to 4 over x, the derivative would be, I'm sorry. That would be the derivative times the natural log of e, and the natural log of e cancels. So that's this one. Let's do this one right here. Okay, now we have an exponential e to the 4x minus 2 in the denominator. This is going to be our u. I guess I didn't write that very well. So our du will be e to the 4x times 4, so we'll put the 4 right there. Well, it needs to say negative 20, so I will multiply both sides by negative 5. So what we have left is negative 5 du is the same as negative 20 e to the 4x dx. And I should have put this as u. This whole thing right here can be substituted for negative 5 du. So we'll rewrite it as negative 5 du. And now what we have left, since all of this goes away, we have 1 over u. And 1 over u, when we take the antiderivative, it requires us to use the natural log. So negative 5 times the natural log of u plus 0, the antiderivative of 0 will be a constant. And then we go ahead and substitute back the u. And remember, we always put the absolute value when there are variables in there. Just a reminder, because you can't take, if that ended up being a negative number, you take the absolute value of that, because you can't take the natural log of a negative number. Remember, the natural log graph looks like this. So the negative numbers are not in its domain. Okay, I think I'm going to make those two kind of these two weird ones where you have to use the natural log, and that'll be it for these two.